For doing this GeoGebra activity, the discovery activity we're going to do in geometry 6.4/5, I'm going to go over to Google Classroom, go to your appropriate class. For this one, I'll just go to my Geometry Master. That's where I put all the stuff for all of my classes. Go to that 6.4 activity, should be at the very top. In the instructions, there's this finding quadrilaterals.ggb. Go ahead and click on that, and it takes you to this page. We don't want to deal with any of these right over here in the middle. What we want to do is push this button that says download, the arrow is pointing down for download. Push that button and it's going to download. Yours is probably going to be at the bottom, right down here where my mouse is moving right now. And when that's done downloading, go ahead and make sure that opens up. So click on it to open it up. I'll click OK to open mine, and it should open in GeoGebra. So this will pop up on the screen, and it'll open up like it does now. It should look like this when it opens up. Now on this we see some instructions. Let's look at these top left instructions first, where it says to make the following note cards. This box I just moved. Make the following note cards. So if you were in class on Wednesday, you've already made these note cards. If you weren't in class, go ahead and make them now. If you don't have actual note cards with you, just use pieces of paper. That'll be okay. And on those note cards or pieces of paper, make these bullet points. Right down here in purple, these bullet points. You have to write everything except for this example where it says a square is more than one quadrilateral. We'll get to that later. But you don't have to write that example part, but write all the rest of those bullet points. So go ahead and pause the video if you need to. But we want you to do that. I've already typed these up in a Word document for mine. Since I'm not making actual note cards on a computer, it's a little different. And this is what the activity starts with, is this quadrilateral here, this four-sided figure, four-sided polygon. And it says drag the vertices until the words pop up on the screen. Make sure to do it more than once to verify that the properties hold. Well, I know what we're doing, thankfully, so I'm actually just going to do it the one time for this experiment, for this activity. Now, a parallelogram. If I go ahead and make ourselves a parallelogram. See right there, parallelogram pops up. Now, I know it's behind that CD segment is equaling to 9. But we know that's parallelogram behind there. So we'll go over to our document here. And we'll know that it's nothing else. Nothing else popped up there. It's just a parallelogram. That's it. We look at the relationship with the sides, what we're asked to do next. Specifically the lengths of the sides. So we start out up here. CD, this top side, is equal to 9. BC over here, this right side is equal to 6.1. BA, our bottom side, is equal to 9. And AD, the left side, is equal to 6.1. So we notice that CD and BA are equal. And AD and BC are equal, or I should say congruent. The opposite sides are congruent. So we'd say that both pairs of opposite sides are congruent. I need to rewrite that. Both pairs of opposite sides are congruent. And that's nothing new. We talked about that in class together when we went over parallelograms in the first place. Now we also want to look at the slopes of those lines. Thankfully our slopes are calculated over here for us. So we have the slope of AB first. Okay, we're told that's 0. Well, we already know with the parallelogram that this opposite side is also going to have a slope of 0, meaning they're parallel because those slopes of those sides are equal. We know, since it's a parallelogram, that AD and BC should be parallel since they're opposite sides as well. We look down at their slopes, -6 and -6. Those slopes are equal, so they're also going to be parallel. So we'll note that we have both pairs of opposite sides are parallel. We want to get very specific with that. You don't just want to write, oh, opposite sides are parallel or sides are parallel. Well, if you say sides are parallel, which sides? So we need to say that both sides are parallel. You say sides are parallel, well, it could just be one pair of sides. It could be two, we don't know. So now we know that it's both pairs. Next, we're asked to look at relationship of angles, specifically the degrees of those angles, the measurements. So we look at our measurement of angle C over here. We have 99.5. We have 80.5 for B. Angle A is 99.5. And angle D over here, covered up a parallelogram, but it's angle D, is 80.5. So we have 99.5 and 99.5. So those opposite angles are congruent. And 80.5 and 80.5. So those opposite angles are going to be congruent as well. So we can say that both pairs of opposite angles are congruent. Once again, you want to get very specific with that, saying that both pairs of opposite angles are congruent. We don't just want to say opposite angles are congruent, because that could mean that one pair of opposite angles are congruent. It could mean that two pairs are congruent. We don't know. Instead, we want to get very specific, saying that it's both pairs. So that's how we want to get specific with all of them. So next, we could go to really any of these. I know how to make them, so I'm going to try and go to, a trapezoid. Okay, so I made a trapezoid. You know that because trapezoid popped up. And this is one of those shapes that we want nothing else to pop up with it, just like parallelogram. So what else is a trapezoid? Well, a normal trapezoid would be nothing else. It's only a trapezoid. It's not a parallelogram, it's not a square, not a rectangle, just a trapezoid. Relationships of sides, those lengths. So we see 9 for this top side, 6.1 for this right side, 8 for this bottom side, and 6.3 for this left side. Well, I don't see any of those being congruent. So we'll just write over here, no relationship. Now if we look at the slopes, we have AB, this bottom side is equal to 0 for the slope. We have AD, the left side has a slope of -3. The top side, CD, has a slope of 0. So that's the same slope as the bottom side. So those two sides would be parallel. That one pair of opposite sides are parallel. Let's look at our right side, BC, or CB as is written here. Has a slope of -6. Well, -6 and -3, they aren't equal. They aren't opposite reciprocal. And so those wouldn't have relationships with any of the other sides. So we'll just say that we have one pair of opposite sides are parallel. And that happened to be this time our top and our bottom side. But we knew that we had one pair of opposite sides are parallel. That's what we knew. So let's go on to the degrees of those angles, the relationships of those. Okay, well we have 99.5 and 80.5. We have 80.5, 108.4. We have 108.4 and 71.6. Okay, well right now I don't see any angles that would be congruent. However, I am seeing that we have consecutive angles here, angle C and angle A, that would add up to 180. These don't add up to 180, but angle D and angle A would, and angle D and angle C would not as well. Well, let's see if that would hold up if we extended D out 1 point. Okay, well those two would still be supplementary because those two didn't change. Now these two, 63.4 and 116.6, that's still supplementary. And we still have a trapezoid. Same thing we could do over here. We would also have supplementary over here because as these angles change, they still add up to 180. So for our angle relationship for this one, we would say that we have two pairs of consecutive angles, and those two pairs of consecutive angles are supplementary. That means they add up to 180. And you'll likely need to keep pausing the video as I'm going along. So now we found a trapezoid. We went over that one. Let's look at an isosceles trapezoid. That's what that would say there, isosceles trapezoid. Now for this one, this is one where, what else is it? Well, it's also going to be a trapezoid. You see that on the screen there? So we go and we look at the lengths with locations. So what are the lengths? We have this top is 14, bottom is 14, and those aren't congruent. We have 6.3 on the right side and 6.3 on the left side. Well, those are congruent. So we'll say that we have one pair of opposite, didn't go far enough, one pair of opposite sides are congruent. That's all we know. We don't have both pairs of opposite sides congruent, but we do have one pair of opposite sides are congruent. Now if we look at the slopes, just like a trapezoid, we'll see that this top and the bottom here, that one pair of opposite sides are parallel still, because it is also a trapezoid, so that's still true. Now if we look at this side here and this side here, our left and right side, we have 3 and -3 for our slopes. So once again, we don't have a relationship on those. So for slope, well, the same thing as we did on trapezoid, where we have one pair of opposite sides are parallel. Going on to the relationships of angles, we look at the degrees with locations. Well, we start up here with angle D, we have 108.4. Go over to angle C, we have 108.4. Well, those are congruent. So we know we have one pair of congruent angles. Where are those at with each other? They're consecutive. So we note that we have one pair of congruent angles that are consecutive. Keep going around the trapezoid, I should say, around the isosceles trapezoid. We have 108.4 and 71.6. Well, those are consecutive angles again. And this time, they aren't congruent, but they are supplementary. They do add up to 180. So we have, so far, one pair of congruent angles and one pair of supplementary angles. But those were different angles. Now, keep going. We have 71.6. We also have 71.6 over here at angle A. We notice those are congruent again. So we have two pairs of congruent angles that are two pairs of consecutive angles, that are congruent. And we have our one pair of consecutive angles that are supplementary. So let's go 71.6 to 108.4 back at angle D where we started. And those add up to 180 as well. So we have two pairs of consecutive angles that were congruent and two pairs of consecutive angles that were supplementary. So over here, I wrote that we have two pairs of consecutive angles that are congruent, or congruent consecutive angles, either way, and two pairs of supplementary consecutive angles. Noting that each pair contained different angles. So not all those pairs were the same. Because when we looked up here, these two congruent angles, they were consecutive, but they weren't supplementary, whereas these supplementary angles weren't congruent. So if I go on to the next shape, and I want to make a kite. So I'll make a kite. So less discovery since I already know what we're doing here. And see, I can make all sorts of kites. Make a kite here, make a kite here, make a kite here, make a kite here. They're all kites. This one probably looks more like a kite you'd buy from a store. Doubting a lot of you are going out and buying kites though. So what else is a kite? Well, we don't see anything pop up yet. So we'll leave it blank for now. Let's keep going through. And let's look at the lengths. So we have 8.5. Oh, over here we have 8.5. So we have two consecutive sides that are congruent. 8.5, and we have 5 as well over here. So we have 8.5 and 5, so that's nothing. We have 5 and 5, those two are congruent. And we have 5 and 8.5, and those two aren't congruent. So with this one, we have two pairs of congruent sides. So two pairs of congruent sides that are consecutive. Two pairs of consecutive sides are congruent. So in this case, it ended up being the left two sides and the right two sides were the pairs. Now I'm going to go ahead and back up and fill what else is it. We didn't have anything pop up, so we'll say nothing like we did before on that trapezoid, because it is nothing else. When we look at slope, we see 0.8, negative 0.4, 0.4, and negative 0.8. So we don't have any of those equal. We don't have any of those being perpendicular, as in opposite reciprocal. So we'll say that there is no relationship there. Don't have a relationship. Doesn't exist. Let's look at the degrees with locations. Well, once again with the slopes, this time we don't have any parallel sides. This is the first shape we've seen so far this chapter with no parallel sides. Take note of that. Now going on to the relationship of angles, talking about those degrees. We have 41.1, 122.6, 73.7, and 122.6 if we go clockwise around, starting with the left side. If we notice those, we have angle C and angle A were congruent at 122.6. We had 122.6 and 73.7. Well, those happen to be supplementary. No, they are not. My bad. They add up to a whole different number than 180. I don't know what I was thinking. So we have these two are congruent. Those two aren't supplementary. These two aren't supplementary. 73.7 is not equal to 41.1. And 41.1 makes nothing with either of those two. So for this one, we have one pair of opposite angles are congruent. So that's a unique one to kite as well so far, is that only one pair of opposite angles are congruent. Now I've exhausted all of these down here. Done trapezoid, isosceles, trapezoid, and kite. So let's go up. We were left with square, rhombus, and rectangle we still need to do because we started out with parallelogram. So let's go ahead and go to rectangle. So I'll make a rectangle. So I made a rectangle. And what else popped up? Well, it's a parallelogram. I actually left that up as well on the note sheet. So it's also a parallelogram. Every time you'll have a rectangle, that rectangle will also be a parallelogram. So if we look at the length of this rectangle, you notice we have 10, 6, 10, and 6. So our opposite sides look to be congruent again, but consecutive sides we had no relationship. So just like with the parallelogram, since it is a parallelogram, both pairs of opposite sides are congruent. Looking at the slopes, well, we have 0 over here, or our AB on the bottom. On the top of the opposite side, we also had 0, so those two are parallel. So we have that pair of opposite sides are parallel, the top and the bottom. On our left side, AD, we have it's undefined, meaning that it's going straight up and down. And on CB, we have undefined as well, meaning it's going straight up and down. So those two opposite sides are also parallel. So we have both pairs of opposite sides are parallel. And that's the same thing that would be true for a parallelogram, which makes sense considering that a rectangle is a parallelogram 100% of the time. So now if we look at the degrees with locations, we notice that we have 90 degrees, 90 degrees, 90 degrees, and 90 degrees. So not only with it like a parallelogram would be, are the opposite angles equal, all 4 angles are equal now. So look over here. All angles are congruent. Every single angle we have is congruent. That's finally true. And each angle is also 90 degrees. Now let's think about the 90 degrees part. If we have a quadrilateral, the internal angle sum is always going to be 360 degrees. And now if we have 360 degrees divided by our 4 angles that happen to be congruent now, each angle would always come out to 90 degrees. So we know that all angles are congruent, which means that all angles are 90 degrees for a rectangle. And just like a parallelogram, they would be supplementary, but we don't need to note that if we know that they're all 90 degrees. That's the important part there. Though it is true they would be supplementary. So let's go ahead and go next to aramis. This one's a little hard to make on here. It's pretty tough. But I'll go ahead and make it here. And there it is. It's our rhombus with the parallelogram popping up. And that is exactly true, that a rhombus is always going to be a parallelogram as well. 100% of the time, a rhombus will be a parallelogram. Now note that a parallelogram was not necessarily a rhombus, just like a parallelogram was not necessarily a rectangle, but just like a rectangle is always going to be a parallelogram, a rhombus will also always be a parallelogram. Will always be true 100% of the time. So we go and look at the sides, and we have 7.8, 7.8, 7.8, and 7.8. Well, if we look at those, we have just like a parallelogram, the opposite sides would be congruent, but now we have all sides are congruent. And that's what's true with a rhombus. All 4 sides are congruent all the time. That's what happens. That's why I knew to put these on the axis specifically to make these congruent. So in this case, I put it at 6 and -6 on the y-axis and -5 and +5 on the x-axis. If you want to make it as well in your GeoGebra. Now looking at the slopes. Since it's a parallelogram, we should have opposite sides parallel. So let's check. We have BC and AD, so they should have the same slope if they're parallel. And -1.2 and -1.2, so that checks out, they're the same. And we should have CD and BA having the same slope since they should be parallel. They have 1.2 and +1.2 as well, so those are the same. So we know that both pairs of opposite sides are parallel. Once again, that's not that all pairs of opposite sides are parallel. It's not that one pair of opposite sides are parallel. It's that both pairs of opposite sides are parallel. Now if we look at the relationship of angles with locations, okay, so we have 79.6. This one's a bit hard to read, so I'll move that a bit there. It's also 79.6 at the bottom. So those opposite angles are congruent, which makes sense with the parallelogram for that to be true. We have 100.4 and we have 100.4 on these opposite sides, which also makes sense for those to be true, that those would be congruent. And what would also be true with the parallelogram is that the consecutive angles would be supplementary. And if we look here, our consecutive angles are in fact supplementary. So if we look over here, if I highlight this text and make it appear, it'll say that opposite angles are congruent. That should say both pairs of opposite angles are congruent. And consecutive angles are supplementary. And that's true for all consecutive angles. So we can say all consecutive angles are supplementary. So those are both true. And that'd be the case with a parallelogram as well. So now we have a square. Might be the easiest one to make on here. So I'll go ahead and make it. Make a decent size one. And so when I make a square, we see square, rectangle, rhombus, and parallelogram pop up. And no matter what square I make, say if I make this a bigger square, I need to make it a square for that to work, but let's say I make it a bigger square. Once again, we have all four of those pop up. So a square, by nature, is always going to be a parallelogram, a rectangle, and a rhombus. So everything that would be true about those is also going to be true about a square. All those attributes. So let's go through and let's find those. So we have this side's 11, this side's 11, this side's 11, and this side's 11. So just like a rhombus, we have all four sides are congruent. And it's also true that like a rectangle and a parallelogram, that the opposite sides are congruent. But even more, just like the rhombus, all four sides are congruent. We look at our slopes, our top and our bottom. Well, they're parallel because they're both equal to 0 for the slope. And our left and our right are both undefined, meaning they're both going straight up and down. So those are parallel as well. So we have both pairs of opposite sides are parallel. Once again, that would be just like a parallelogram. So if we look at the relationship of angles, specifically the degrees of those, we have 90 degrees, 90 degrees, 90 degrees, and 90 degrees. That was the same as the rectangle that we just had. And what we found true to be with the rectangle was that all four angles are congruent and equal 90 degrees. Once again, that's the same as the rectangle would be. And just like a rectangle would also be, we know that the consecutive angles are supplementary.